Next up, we're going to talk about the phospholipids. These consist of a lipid, like a fatty acid or something like that we'll see, attached to a phosphate group. And one key thing here is they are what we're going to call amphipathic. Amphipathic means that they contain both nonpolar and polar parts. Be sure we understand that term. So has both polar and nonpolar parts. These are a major component of cell membranes. So when we're talking about putting together our membranes here a little bit, this is what a lot of membranes are consisting of, is these phospholipids. A little bit more specific here are the glycerol phospholipids. That means they're going to contain a glycerol core, kind of like fats did, kind of like the triacylglycerols, but a little bit different this time. And the key thing is then it's going to be what we'd call a diacylglycerol. So this is DAG, diacylglycerol. And if that has a phosphate group added to it, we're going to call that a diacylglycerol phosphate, or DAG-P. I might call it that way. Something like this, right? So I'll refer to them as that. What do these look like? How are these put together? So there are, in addition to just that backbone diacylglycerol phosphate, that phosphate then can have various groups attached to it, shown here. These are what we call Z groups. They're these accessory groups that go on there. And so I don't need you to memorize these structures, although we're getting familiar with some of these, certain serine amino acid, for example. But what I want you to recognize is these all have very different properties. If I just had a proton or a hydrogen on here, then that phosphate group would just be kind of like phosphoric acid, so we call it phosphatidic acid is what that particular molecule would be. We could put something like serine on that phosphate group, and it would have some properties that we are familiar with at pH 7, right? This COOH would deprotonate because it's a carboxylic acid and become negatively charged. The NH2 would gain a proton and become positively charged. So charges can change. We could have other things like just a single positive charge like this ethanolamine. We could have choline, which you might remember we saw with some of our enzyme examples, which would always have a positive charge. We could have things that just have a lot of hydroxyl groups. So this thing called inositol could be added on there, just a ring with a lot of hydroxyl groups that isn't charged, but is certainly very polar. So depending on the needs of the cell, depending on the needs of the lipids that are in the membranes, we'll see different properties here. So that's fine, but what I want to do is draw what one of these would look like. So for example, I'm going to draw sort of the core glycerol backbone first. Remember, glycerol is, as I was saying, is kind of like we just have propane, right? That's propane in line angle notation, but propane with a hydroxyl group coming off of each of the carbons. I'm not going to draw them as hydroxyls. I'm going to draw them just as oxygens for now. So that would be glycerol if I put H's on each of those O's, but they're modified. And so what's similar here is that there are two lipids, two carboxylic acid or fatty acid lipids attached to two of these oxygens through ester linkages. So this would look familiar when we remember talking about our triacylglycerols, or the fats. So this would look like this. I've got an ester linkage like that, and I'm not going to be very specific about what the particular fatty acid is. We'll just say etc. like this. But I've got two of these now. So I've got another one here, and again, it could certainly have some double bonds in that chain. It could be different lengths. We're not too concerned about that. We're just looking at the overall structure right now. So remember, this is called a diacylglycerol. So remember, here's the glycerol. This is a diacylglycerol because they've got two acyl chains. Remember, when we have these in ester linkages, we have that OYL, oil ending, and we said that they're acyl linkages when we have that ester like this. So that's the diacylglycerol part. And then there's the phosphate part then on the left-hand side. So we've got the oxygen, and we dealt with phosphate a little bit earlier on in the course, but now we're going to see it a lot more. So phosphate looks like this, where I've got one of the oxygens has a double bond. The other three oxygens have single bonds. One of these will carry a negative charge, and the other one is going to be bonded to the Z group. And remember, the Z groups are these things up here. So notice again that these are amphipathic, meaning that it has polar and nonpolar parts because it's got this lipid tail here of varying lengths that will be certainly nonpolar. And then it has this head group with this phosphate on it that will certainly at least have a negative charge. If not, depending on the Z groups, have other charges, positives, other negatives, or maybe just a large polar group like we have right here. So again, we have a core structure that we can put various decorations on to change the properties of that molecule.